So in this example, refer to the picture, draw a vector that represents the average velocity vector for t running from 3 to 3.5. So let me explain this picture. In this picture, the curve in red is given by r of t, and we're just, it's kind of generic, right? I'm not giving you a formula for r of t, but I'm telling you that r of 3 is this point, and if you think of it in terms of an arrow vector, then it's the tip of this arrow. And r of 3.5, I'm saying, is this point on the curve. And it's the, if you draw in the actual arrow, which we don't always do unless we need them, it's the tip of that arrow. So an average velocity. Okay, let's write down that velocity formula again and the limit definition. The limit as h goes to 0, I almost said f of t plus h, r of t plus h minus r of t all over h. What do we do with this formula if we want it to be approximate? What do we lop off? When we lop off the limit, we change it to, for small h, v of t will be approximately equal to that vector difference quotient, right? This is for small h. This is for, now I'm not specifying how small, so I'll put in quotes small h. So the best I can do, since I'm not given much information here, the best I can do is use this formula and the given picture to draw a vector that might represent the average velocity. So this is, or really it's this formula represents average velocity. And that's from t to t plus h. Well, here's how I remember how to apply it. It's like the slope formula. If you just add the t and the h values together, it really looks like the slope formula when you want to find the average velocity between two outputs, 2 points generated, or 2 tips of the arrows generated by the vector valued function. You put on top then, and I'll relate it to this vector difference quotient in a second, but think of the slope formula for now. You take the difference between the output values, r of 3.5 minus r of 3, over the difference between the input values, 3.5 and 3. Doesn't that remind you of the slope formula? It's easier to think of for me that way. But it really does conform with this formula, because what's t here? What's t here? T is, well, the beginning value of t really is what I mean, is the 3. And what's h? The 0.5. So you take 3 plus 0.5, oh, that's this guy. That's the t plus h for that given value of t. And then there's the t. So r of t plus h minus r of t. And then on the bottom, isn't 3.5 minus 3, isn't that h? Yeah. But again, if you like that idea of slope, yeah, then use it. If not, just plug directly into the difference quotient. So, okay, so what does this really equal then? Do you guys see that it's really, that this equals twice r of 3.5 minus r of 3? Because what is this on the bottom? It's 1/2. 0.5, which is 1/2. When you divide by 1/2, you take the reciprocal and multiply, right? So that's where this comes from. That gives me a way to represent, using my picture that I've already drawn above, it gives me a way to fill it in with your average velocity vector. Because I know, let me use purple. Would everybody agree that just that the numerator, the original numerator, r of, let me make that thicker. Does that show up okay? Let me make that a little thicker. Okay, so that vector in purple there is r of 3.5 minus r of 3. Just think tip minus tail, right? So if I want to make a vector twice as big, which is going to represent my average velocity vector, then all I have to do is make that vector in purple about twice as long, right? So let me grab hold of that vector in purple. Maybe I should do a new one just because on paper you won't be able to grab a hold of it. So how about in blue? So there's r of 3.5 minus r of 3. Make it about twice as big. Stop me when I get there. Right, close enough, right? So there it is. So there's your average velocity vector over the interval from t equals 3 to 3.5. It says write an expression for v of 3. So t equals 3, but it's going to be symbolic. So we have to, that's the only thing we can do because I didn't specify what r of t is. So there's no way you can find v, right? Which is r prime. And there's no way you can evaluate it at 3 except symbolically representing it. So all we have to do is take that limit of the difference quotient. Limit as h goes to 0, r of t plus h minus r of t all over h, and plug in t equals 3, and we've got our representation. So v of 3, so this is v of t, symbolically, the definition. And so v of, 3 would be, it would look just like that, except we'd plug in a 3 where the t is. So limit as h goes to 0 of r of 3 plus h minus r of 3 all over h. So that problem's just to get you used to the symbolism.